Hey everyone, it's Jim
and Charles
from Mellow amps. And now that we've cleared the electrical voltages, what if we didn't clear them? What if we had a small problem? What if we're not sure about something? What if later on our amp develops a little bit of a problem? Well,
time for troubleshooting.
So let's just back out, and the manual actually has a troubleshooting guide. Caution, high voltages present. So yeah.
So first things first, if you're poking around inside here, make sure it's discharged first and make sure it's unplugged and safe to work in.
Yeah, and when you've got a problem with a piece of gear, it always, and our kits are extremely reliable. They go through many iterations and many prototype builds, and then the test builders put a lot of time into making sure that there's no problems hiding that we haven't found yet. But maybe later on, a year down the road, you develop a problem and you're not sure. Well, see if you can figure out using the troubleshooting guide and hone in on what possibly could be wrong. You can always contact us if you're in doubt. In fact, if you're in doubt, you should always contact the manufacturer before you go any further. With any tube gear, the most common problems you're going to have are the tubes, because the tubes are fragile. Yes, they're built robustly, but they are, if you're old enough, think about an incandescent light bulb. Those light bulbs did not last forever. They lasted a long time, and then they'd either fade away or they'd go pop.
Yeah, so they are consumable items, and just like incandescent bulbs, they have a filament in them that can fail over time.
They also can become noisy, and even though the 6AS7 and 6080 is an extremely robust and very reliable tube, it was made for military use, industrial use, big power supplies, they still can go bad. And it's not common that they do, and they're actually very long-lived tubes. But yeah, so think about the tubes first and see if that issue shows up here. The other thing that's really common is that fuses burn out. So if you've got a year or two on your amp and you've popped a fuse, that doesn't necessarily mean that you actually have a problem.
If you pop two fuses, it does.
That's right. So if you replace the fuse with your spare and it immediately pops, stop. Now you know you have a problem. Now you have to investigate it properly. Do not, and I mean do not, put a larger fuse in to solve the problem. That will create a major hazard. Okay, so if you've built this kit, you're very familiar with how it all goes together, and you've got another tool to help you go deeper. So after you've gone through the basic troubleshooting guide, grab your schematics. And the way you troubleshoot is you start at the beginning. So unplug the tubes and start by probing your voltages and moving forward. So here we're in AC, so you would take your volt ohm meter or your multimeter and you would switch it over to AC. And you would start by probing this voltage here at J1. And after J1, you're rectified, so you're now DC. Even though you're really raw DC at this point, you're still DC, so you would switch over to DC. So if you found this voltage to be correct here, or in the ballpark, close ballpark, then you know everything from here back is good. You also want to always look for stable voltages. If your voltage is bouncing up and down like a yo-yo, that's a sure sign of problems. Now, it could be the household mains voltage, but most likely it means you've got a problem in the amp. So we're going to have to locate that problem. So if this cleared, we would switch over to DC, and then we'd move forward, and we'd keep on probing, and we keep checking. Everywhere we have voltages, we'd look and see whether we're in the ballpark.
Now these are all loaded tube voltages, but as we saw whenever we did our startup testing, the unloaded voltage is going to be somewhere around 25-30 volts above this unloaded voltage. And it's not going to drop very much across these filter stages because we have very little current flowing through the circuit.
That's right. So you can see here, if we read note 5, the notes are really informative. They're there for a reason. Note 5 tells us that with no tubes loaded, we'd have about 184 volts DC. Now, this is really important. All voltages are approximate because as your mains voltage goes up, the voltages will increase. As your mains voltage goes down, the voltages will go down, and in proportion to your mains voltage. So 184 volts unloaded over here, but with no load on it, we'd see somewhere close to 184 volts going backwards. So we're moving forward, so we'd be looking for something like that. So what you could do is you'd start here and check it. And if you actually found something in the ballpark of 184 volts DC on both sides here, then you know that actually the power supply is just fine. If not, you'd go backwards and look for the area where the voltage shifts, and that should point you at the component that's either installed incorrectly or that has failed. So once we troubleshoot the power supply, we turn the schematic in the correct orientation so we can read it. And we do the same thing. So if the power supply is clear, our B plus coming onto the plate should be roughly this.
With the tubes loaded?
With the tubes loaded. And in fact, if the power supply had cleared, I would load the tubes now, and I'd be looking at these voltages and seeing if they're in the ballpark.
Now, if either of these have shifted substantially, it could be anything in this circuit here. It could be something wrong with the tube, could be something wrong with the cathode resistor, the wiring in this area going to ground, or possibly even something wrong with the grid leak resistor over here. So if there's something wrong in this section, make sure you take your time and check the values on all these components and make sure they're checking out.
Yeah. Now, what Charles said is really important. Take your time. So troubleshooting is not a job to do when you're half asleep, you're frustrated, you're angry, you are going to listen to your favorite album on your brand new headphones, and all of a sudden you've got problems and you've lost a channel, or you've got a lot of noise, or something just does not sound right. So you've done the smart thing. You've unplugged the amp, you've put the music away, but it's later at night, you're tired. That is not the time to be doing troubleshooting. So think about it. Know that you've got a video, you've got a troubleshooting guide, you've got a company that values its customers above all else, backing you up. Go ahead, and that's actually Willow having a little bark. So Willow's just our neighbor's dog, and she's just delightful. I got to spend Sunday with her, and it was a lot of fun. Anyways.
So go ahead and have a sleep on it, which can sometimes help you troubleshoot just on its own, and come back to it the next day when you're well-rested, clear-headed, and ready to tackle the problem.
Yeah, and if you're not sure about something, drop us a line, because, we designed the circuit from the ground up.
And we've made all the mistakes already, trust us.
Well, I don't think we've made every mistake, because we try and avoid mistakes like the plague. But yeah, we've done quite a few goof ups along the way. So yeah, one of our favorite goofs up is when we start up an amp for the first time and we forget to put the primary fuse in, and we say, holy smokes, there's no voltage.
Yeah, we remember that this time, thankfully. Maybe it's a sign of a good trend.
Yeah.
So with all this troubleshooting, one of the most common things that we see is somebody puts a resistor in the wrong spot, installs a capacitor backwards. Now, hopefully that hasn't happened here, because these big caps are really hard to get off. But if you've taken your time, those should be all okay. The resistors are easier to fix if there's a problem there, but hopefully they're all in the right spot. And hopefully you don't actually need this troubleshooting video.
I mean, basically, even though there's a fair number of components, the circuit's actually very simple.
Yeah.
And that should make for a long-lived, great-sounding, reliable amp. So, yeah, I think it's time to get our first track teed up,
Well,
Charles?
actually, one more thing first. In all of this, you want to make sure that your coolant system is running optimally. So you need to have active cooling going on in this. The bottom panel, once it's on, it's going to draw air through it, over these big resistors on the heat sinks, and then out through this fan. So if this fan isn't running, you're going to burn out your amplifier. You're going to burn out these resistors, possibly damage your tubes. It's not going to be a good time. So make sure you have good airflow. You don't have this sitting on a fluffy towel or a blanket or something, that you don't have anything blocking this back fan port. You're not running a space heater next to it or something like that.
Yeah, and in our in-system video, which is coming up really shortly, we'll actually talk a little bit about where is a good place to locate this and where is a bad place to locate it in system. So, yeah. Okay. Yeah, let's get some music playing.